search. I'll quickly go over the solutions to last week's problem set over sorting, just in case you guys needed some help over that, or you guys wanted to see the solutions. So let me share my screen real quick. Here we go. Oh, okay. And I'm going to assume that you actually, I guess I'll quickly go over the problem as well, in case you guys have not seen that. But for the first question, which is passing the gate, the question is asking that so that once we're given a set of numbers, we want to print them out in sorted order. So what we're going to be doing for this question is first we're going to be reading in the numbers as usual. So we have int n equals the next integer because this is the number of elements in the array. And next we read them all into this array like this. ARRI is equal to the next integer that we read in. And now once we're done with that, we use the method arrays.sort, which automatically allows us to sort the elements in an array, and it's actually really useful. And after we call this method, the elements in ARR will actually be sorted automatically. So from here, all we have to do is print out the elements, as that is what we need to do in the output. And as you can see, we were able to pass all of the test cases in under 0.2 seconds. So that was passing the gate. Next, let's go into the second question, which was passing the locked door, and was a bit harder. So for this question, unlike the previous one, instead of having to print out the numbers in a sorted order, we now want to print out specific numbers. So once again, we are given first, in the first line of input, the number of integers that will be given to us, and then a sequence of integers. So once we're given this sequence, we want to be able to find the minimum, median, and maximum of these numbers. And obviously, it is actually possible for us to do this without sorting the array with like some complicated stuff, but it's much, much easier to actually finish this problem using with the sort function. So if we quickly go to the solution for this. So after we read in the array as normal, what we do is first we sort the array using arrays.sort as we did in the previous question. But now, instead of just printing out every number individually, we will print out ARR0, which is the element in the 0th index for the first number, ARRn/2, which will give us the number in the middle of the array, and ARRn-1, which will print out the last number in the array. And note that n is the size of the array, which is why this works. Does anyone have any questions so far? All right, well, hopefully the silence means that no one has any questions and not that I'm doing a terrible job explaining or something, so everyone is super confused. But let's move on to the final question, which is passing the pit of zombies. So unlike the other problems, instead of only having one number in the first line of our input, this time we're given 3. So the first number represents the number of elements in our array. The second number represents the number of even elements in the array. And the third number represents the number of odd elements in the array. And then the second line of input, as always, will just be the numbers that we have to will just be the numbers in our array. So given these numbers, what we want to be doing, as shown in the output format, is we want to first output the even numbers in increasing order. So out of 2, 6, 1, 3, 4, and 11, the even numbers will be 2, 6, and 4. And when we output them in increasing order, that would be 2, 4, 6. And then after we're done with that, we output the odd numbers in decreasing order. So since the odd integers are 1, 3, and 11, then we want to output them in decreasing order, which would be 11, 3, and 1. So given this pretty difficult problem, let's see how we might go about coding this. And let's ignore the wrong answer below, but it's fine, guys. Anyways, so unlike for the other problems, since for this problem, we have to output first the even integers in increasing order, and then the odd integers in decreasing order. Instead of just storing it in one array, we'll store it in 2, because this will allow us to sort of first sort the even integers, and then sort the odd integers. So as always, we first read in n, x, and y, which represent the number of elements in the array, the number of even elements in the array, and the number of odd elements in the array respectively. And we would create 2 arrays, which will hold, array 1 will hold the even integers, and array 2 will hold the odd integers. So from here, we do a sort of a different sort of way to read in the input, because instead of just automatically reading the next number into our array, since we have 2 arrays, we first have to check if the number is even or odd, and then put it into the specified array. So as you can see, first we read in the number, then in this if-else statement, we check if the number is even or odd. If the number is even, then we insert it into the next open slot in our even array, and if the number is odd, then we insert it into the next open slot in our odd array. And this actually fills up both of our arrays. So now from here, we have array 1, which is filled with even integers, and array 2, which is filled with odd integers. But since we want them in sorted order, we do arrays.sort for both of them. And this will sort the even integers into ascending order and the odd integers into ascending order. And luckily, since what we want to do is first print out the even integers in ascending order, then we can just print out the elements of the first array like this. But for the second one, since we want them in decreasing order, we can't just automatically just print them out in order. Instead, we have to start from the back and then print going down to the front. Because the elements in array 2 are sorted in ascending order, but we want to print them in descending order. So instead of printing them from indices 0 to n-1, we start from n-1 and go to 0, because this will give us the backwards order that we need. And like that should be enough to finish the problem, because this gets all the test cases. So since that was quite a bit more challenging, does anyone have any questions before Akash goes on to his very brilliant lesson over comparators, comparables, and binary search? And yeah, feel free to ask anything. Like, there are no bad questions. And also, it makes me feel better if I can answer a question. No one? Oh, well, all right then. Hopefully that means I explained it extremely well and no one has any questions. So yeah, Akash, feel free to start your lesson now.
Okay, thank you, Rich. All right, I'll share my screen. Okay, so as Rich has said several times already, we're learning comparators and comparable as well as binary search this week. So the first thing we'll do is we'll go over comparable and comparator. And there aren't that many people here, so, and like I also don't have it open, so if you have a question, just like interrupt me and it'll be completely fine. Okay, so starting with comparable and comparator. Okay, so in Java, we often have to make comparisons, and Java comes in with many built-in classes and methods that revolve around comparisons. Some examples of these, which you might have not been exposed to yet, but like probably like will eventually, are things like priority queue and tree set, but also ones that you have exposed to that Rich actually use, collections.sort and arrays.sort. So both of these specific classes sort the array based on like some like value. So when you use array.sorts on an integer array, it like sorts it in ascending order going like 1, 2, 3, 4. If you use arrays.sort on like a string array, it sorts it alphabetically like A, B, C, D, E, F, G. And so that's all the thing. But what if like we have like a self-made object that we want to sort and Java doesn't really like have a solution and we need to end up coding it ourselves? And that is where comparable comes in, because we can add comparable to classes to do that. So comparable in Java is a thing called a Java interface, which I don't know if we like went over that yet, but the main thing is when we like look at the code, the thing with the interface is there's two key things that that classes do with it. So first, I don't know if you learned in like we probably went over already, but like object inheritance interface is somewhat similar, but instead of extends, it uses implements. So certain classes will implement the comparable interface, which will become clearer when you use a code. And the main thing that implementing the comparable interface is that it means the class has to have a method called the compare_to, which we'll go over in the next slide. And if we have objects and classes that implement comparable, then we're able to use like a lot of the built-in Java features, such as collections.sort, arrays.sort, things like priority queue, in order to like specifically sort the array. So a comparable class, the comparable class, like I talked before, has this thing called a compare_to method. Every single class that you write that implements comparable will have to have a compare_to method with this exact signature. The signature is public int compare_to, and then in parentheses, E variable name, where E is like the class the object is in. So this method functions as follows. When this method is basically called, since it's not a class method, it's an object method, meaning it's called with like like an X object dot compare to a Y object. And then this method, as you can see, it would return an integer. So when the method returns a 1 or any positive value, it basically says that like x is considered greater than y. So for example, if you do like 10, like the integer, like an integer 10 dot compared to 5, whatever, it would return a positive value because 10 is greater than 5. And then when an array is sorting that, it'll put it after. Similarly, if this returns a negative value, then y is the considered greater one. So if we do like 1 dot, like a variable storing 1 dot compared to 10, then we want it to return a negative answer because the 1 would come before. And if this method returns 0, then they're considered the same value. So it's okay if that like didn't make a lot of sense. I'll explain it in like context of the code. So there too, right? So then we can use things. There's this method called collections.sort, which you'll use often, and it's very similar to arrays.sort. It just collections.sort lets you sort collections, things like array list or linked list, and it sorts them in natural order. Natural order is what we discussed before. If it's like greater, then like it comes after in the natural order of sorting. So collections.sort is just a method that will take like an array list of objects and then sort it in the natural order. So here it is in the context of the code. So first, comparable. So we have an object class here, and the object class is called movie, and we have our thing like we have private attributes, and then we also have a constructor to set the attributes. But the specific things that we want to notice in the instance of this is comparable. So the first big thing is this implements comparable and then movie right here. So every class that you want to like implement comparable in, that's the first thing you need to do. So you have class, the name of the class, then you have to write implements comparable, and then like in these like weird things, I don't know what they're called, these triangles, I'm not sure what they're called. You have to put the class name, and that's just like something generic you have to write on the top so the code can like recognize that you have a comparable object. And then the big thing is this method right here, public int compared to movie m. So this is the way you write it, as we went over before. And then essentially what this does is it means when we attempt to sort a movie object, it will sort it by year. And if we like analyze this method, it does this dot year minus m dot year, which means that if a country has a greater year, it'll return like if the country it's being called on has a greater year than m, it'll return a positive value, and therefore it will come after. So we note that this array will be sorted if like when we attempt to sort it, it'll be sorted by like ascending year. So it uses this specific attribute. Now, a couple things to note is the compare to method, you can write like whatever you want into it. You could just like have it like return a random integer, which is obviously useless, but technically you can do that as long as it returns an int. So instead of like return this dot year minus m dot year, we could also do like return this dot rating minus m dot rating, or we could do this dot name dot compare to name, and those would all be different ways that we could sort the array. Or we could use like a combination of the two. So we could return like this dot year times this dot rating minus m dot year times m dot rating. And all those are just like different ways that you'd end up sorting the array, which would each do a different thing. But in this specific case, it's using years. So if we go to the next slide, we can see the result of this and like how this would actually be implemented. So we have this movie which extends comparable. And what you can see here is we are creating like an array list of movies. And each of these movies, and then into the array list, we're adding 4 different movies with all these different attributes. So right now, like just the order that like this array list in, it would just go Force Awakens, Star Wars, Empire Strikes Back, Return the Jedi. But then we call this handy dandy method collections.sort list. And now we can call this method because all of the list objects are movies. And as we showed before, movies implement comparable. So we can call this collections.sort method on them. And what that's going to do is it's now going to sort them according to the